Hi everyone, welcome back to JDCodebase. In this video, we will learn how to insert nodes in a doubly linked list using JavaScript. In the previous video, we understand what a doubly linked list is, how it has both previous and next pointer. Now we will move ahead and see how to insert new nodes in it. So there are three types of insertion we will cover. Insert at the start, insert at the end, and insert at a specific position. So let's start. Before we insert, we need to know what a node look like in a doubly linked list. So here the node structure is class node and constructor data, and you can see each node has three things: data, the actual value, previous pointer to the previous node, and next pointer to the next node. Now next, let's make our main doubly linked list class. So class doubly linked list as a constructor, this node head is equal to null. So we will store our head here, which always point to the first node of the linked list. So alright, now we are ready to head insertion logic. So let's begin with the first case, insert at the starting position. So logic is simple. First create a new node, then point new node next to the current head. Then if the list is not empty, make sure the current head previous point back to the new node, and finish make this new node the head. So let's move to VS Code and write the code for this. So let's start with the const new node is equal to new node and data. So here I create a new node here, and we have to check whether this linked list is empty or not. If it is not, if it is empty, just write this dot head is equal to new node and return this. After that, if it is not empty, means it has already nodes, then new node dot next is equal to this dot head. And we also have to convert the connect the previous node also. So this dot head dot previous is equal to new node, and this dot head is equal to new node. So first we create a new node here, const new node is equal to new node data, and then we check if the list is empty, that means head is full. We just make the new node as a head. Otherwise, we link the new node next and to the current head, and also link the this dot link the head previous back to the new node, and finally we update the head pointer. That's it. Insertion at the start is done here. So if I run this node 18 and I get null 10, 20, and 30. If you see, I start the insert at the start 30, 20, and 10. I get 10, 20, and 30. So let's move to the insert at the ending position logic. So here we have to create again a new node as usual, and traverse till the last node, and set last node next is equal to new node, and set new node previous to the last node also. So basically we have there is a one more step. Like if I show you the here, if you see insert at the starting position in the linked list, if I write here, see, I just const new node again same, check whether this is empty or not, and check new node dot next is equal to this dot head, and this dot head is equal to new node. So basically both are similar, just this line is new here to connect the previous node. Now let's start the insert at the ending position. So again write the const new node is equal to new node data, and check whether this dot head is empty. If it is empty, then new node, and return this. Else make a current and temporary list here with this dot head, and run while current dot head current dot next and update this current by current dot next every time, and it runs till the last position. And after that we have to current dot next is equal to new node, and new node dot previous is equal to current. Just similar like we already in the insert at the ending position. So if we check first, we create a new node, then we check if the list is empty or not. Again, that becomes our head. Otherwise, we start from the head and keep moving till the last node. Current dot next is equal to current dot next. Then connect the last node next to the new node, and the set new node previous to the last node, and that's how we insert at the ending position. So if I run this, I just insert at the ending position 40. If I run this, I get 10, 20, 30 and 40. Now next is the insert at the position. So here the logic is goes like that: create a new node and traverse till index -1 node, and then adjust all 4 pointer. Means we have to adjust here 4 pointers. Now new node dot next is equal to current dot next, and new node dot previous is equal to current dot next dot previous is equal to new node, current dot next is equal to new node. This way the new node gets connected both forward and backward properly. So if I say, I just write 30 and 50 here, and I want to add this 40 here. So as we know, I have this next, and this has a previous, and also has a next here, and this has a previous and next. We run till this 30, and then we connect new node dot next is equal to current dot next. Means current dot next is this 50, we connect this, and new node previous is equal to current. Current dot next dot previous is equal to new node, and current dot next is equal to new node. Means we have to connect this to this, and this to this, and this to this, and this to this. Means we have to do this 4 operation, 1, 2, 3 and 4, and just that this way the new node get connected both forward and backward properly. So let's write the code here. So first check if the index is the 0, means it is the this dot insert at starting position, and return this. After that means we have to create a new node const new node is equal to new node data. Then let current is equal to this dot head, and let I equal to 0. Means we have to traverse till the that index, and also check whether the current is not come past the pole, means out of range edge case. I is smaller than index -1, and every time we have to update this current is equal to current dot next, and every time we have to increase this I. As similar that insert dot end, just we are checking this I index -1. Now we have to connect this both 4 pointers. New node dot next is equal to current dot next, and if current dot next is has, then current dot next dot previous is equal to new node, and then current dot next is equal to new node, and new node dot previous is equal to current. So let's understand this step by step. First we check if the index is 0. means we just call our first function insert at the starting position. Otherwise we move till one node before the target position, means by using this while loop. Then we connect all the pointer properly by new node dot next is equal to current dot next, and by writing this. And if we try to insert at invalid position, we just print the index out of range. So let's run this. Let me uncomment this. Means I want to just add the 25 at the position 2. Let's see. Yes, it was 10, 20, 25, 30 and 40. We just add the 25 at the position 2. So let's quickly summarize this. We see the insert at the starting position, update head pointer. Insert at the ending position, traverse till the last node and then update. Insert at the position means update both next and previous carefully. Each operation maintain a doubly linked list two-way connectivity. So in this video, in the next video, we will learn about doubly linked list deletion, how to remove nodes safely without breaking the links. So that's it for the videos. If you find this helpful, make sure to like, share and subscribe to JDCodebase for more short and simple DSA in JavaScript tutorials. See you in the next one.